So today on the bench, we're going to take a look at this digital timing light. And this belongs to a good friend of mine that I work with. And he said that it used to work well. And the last time he went to use it, the timing light didn't work, even though it showed up like it was trying to work. So he has taken a couple screws out of it. So we'll just look into it and see if there's anything we can do. Right off the bat, he is a very, very intelligent person, so the fact that he hadn't fixed it yet is a little bit worrisome. But I think this company, if I understood right, these sell for like $130 or so, and I think they want like $90 to repair it, so what a shame. I mean, you got to be able to repair your stuff a lot cheaper than you sell it new. That's just a given, should be anyway. Okay, so the board is attached to this side. If you can see that, it just looks like some sticky back tape on that high voltage capacitor there. And I'm going to have to peel that away like so. So we can have a look at it. So this is what we have here. We got our signal going to our pulse, I'm assuming, for our strobe, our transistor. We see transformer diodes, another little small Q1 transistor there, some more resistors up under the high voltage capacitor. And we see T2, which is definitely a high voltage transformer, another high voltage capacitor here, C2. So don't see any corrosion or any bad connection, other than D3 does have some corrosion on it, if you can see that. I don't like the looks of that. Let's just go ahead and check D3 right off the bat here. First thing we will do is make sure this capacitor doesn't have any charge on it. And then we'll check this. And that diode does seem to be okay, even though we got a little corrosion clean there. We do have a pretty bad solder joint here, but on it with the meter on the wire, the white wire lead itself, all the way up to the pad here. So checking it up on that, all the way to that C5 capacitor, it actually ohms good. So even though it's not pretty, it's actually a good connection. It's kind of odd here on the transformer. We have a lead here. It's not even soldered, just put through the hole. And one thing that's really cool is, without schematics or information, it's a little bit more difficult to repair something, but this tells us on 1 through 5 here on connector con 1, or connection 1 here. Our white's going to be our flash. Our red is supposed to be plus 12. Pin 3 is supposed to be VCC if you have a LED, and we don't. The black is ground, and the green is shut down. So a little bit more information as we put pieces of the puzzle together here. I'm going to take this cover off as well. We can just have a better look inside. So back now with this INNOVA timing light. I went through several components. I don't like the looks of that diode corrosion, but I don't think I showed it on camera, but I did go through, and the diode actually shows like it's, at least it checks fine, should I say. And this one here actually shows it both ways, depending on how it goes across that transistor. I hadn't drawn that out. It's a 2 microfarad high voltage capacitor, and I have a capacitor checker as well, but a real quick meter check, and we're showing 2.5 micro. These other capacitors showed okay as well, checking from the back side. I actually want to hook this up and see if I can make it run on the bench, and there's several ways I can do that with a little inductive pickup. Of course, having an engine running would be great. That's not going to happen, so I need something that's got a pulse or a spike. And instead of reinventing the wheel, I'm going to bring over a pretty familiar little setup with a brushless motor and little brushless motor controller. And I'm going to give it some RPM, and we probably can pick up enough spike to show some RPM. I'm also going to hook me up a 12 volt supply here. Make sure my alligator clips on the floor ain't touching anything. Going to hook this up, and our meter should power up, or our timing light should power up. 11.9 volts. And of course, it's not going to do anything until it picks up a signal here. So I'm going to cut my power supply on. Sorry about the noise. As I give this a little bit of RPM, you may be able to hear that as it picks up RPM. You can hear the high voltage output actually enable. For example, flip this over. When we see the RPMs go up here and our strobe indicator little icon starts flashing, then we know that this high voltage board should be putting out. And you can kind of hear it singing. I'm gonna slide this over out of the way, but we know what that's doing. So of course, this should be our 12 volts here, right at it. My battery's pulling down a little bit, but looks like we got a 5 volt regulator here, which obviously that should be working fine because our display and all is working. I don't fully understand what this flash and the shutdown is, but one thing with this singing, we're going to be very careful here, but we should have like 300 to 500 volts on this capacitor right here. And there we go, right at 345 volts. So our high voltage portion is working, but the way these xenon bulbs work is it's basically like a gas discharge tube that even that voltage is not enough to flash it or make it arc over the xenon gas, but a high voltage pulse right here to the little trigger, of course, it ionizes the gas and makes it flash. So we're not getting that trigger. So we got to figure out why. And hopefully it's not in this microcontroller or something odd. Just my lack of knowledge on these. I don't understand why I'm getting 4.9 volts on the flash. And if I do go to hertz, on the AC side, I don't see any frequency. I do see a frequency output on what's called the shutdown. I might have to get an oscilloscope and look at that. But if we look real quick, on this flash, the white wire, it's actually coming off of this transistor. And it looks like this transistor is controlled, it looks like all the way to this top left pin number 1, which is like an output pin. Let's go back to volts DC. I'm still getting my 4.9. So I wonder if that pulse or drops to 0, if it would actually flash. So I'm getting 0.016 volts on that pin. And there's my 0.016 volts on this transistor. So if we gate that transistor, so if I go to diode mode here and just be careful, eject a little bit of voltage, go to ground. If I eject that, I don't know if you can see that or not, I just made it flash. So ground, transistor, let's gate it. So I also wonder if I just take this little LED, since I'm getting 5 volts to ground and flash, so if you can see that, if I pull that output down, I can definitely make it fire. So I don't think anything's wrong with this direction. I don't believe it is. We know the bulb's working. We got to figure out why the microcontroller isn't gating this little transistor to fire the flash. That might be actually kind of difficult. So we change our firing angle. I don't know if you can see that on camera. If we change our angle a little bit, we actually are getting a little bit of erratic strobe there. It's not what it should be. So back now, while this thing's working intermittently, let's see if we can get a signal on the scope here. I got it where you can see it, and I can't see it the greatest, but let's see what we can do here with this like intermittent issue. If I go to the, I knew I was getting like a 2 kilohertz signal on the shutdown of the green wire. Let's see what that looks like. Bring the trigger level. When it fires, the pulse width changes. If I go to the flash or the white wire, I really don't know why that is. So we put our oscilloscope on this diode 13 here and give us some pulse in. We hear it singing, and we do see a pulse train. A little bit odd, but as we go up, we do see the frequency change on this signal. So I do assume that is an input, if you will, to the microcontroller. That's showing like 4,000, by the way, just where we got it set up. If I turn this on down, we can go, 2,500 or so. So at 2,500 RPM, we're getting this signal here. But the signal that comes out of the microcontroller looks like this. So I just don't know why that is. I wish I had a little bit more information about, well, a lot more information about this particular board and circuit. This part up here seems fairly simple. This here with the microcontroller is hard to know why it's not gating, I believe, that transistor there to fire your actual, your trigger pulse for your xenon flash. It does it sporadically, so at this point off camera, I am going to let the capacitors just drain off here, and I cut all this off. I'm going to unsolder the diodes from the backside and just check a few components just to make sure everything's working as it should, and that might be as far as we can go with this one. So I've removed one lead off both of those diodes. I'm also just going to remove this high voltage cap because there's components up under it that I really can't see. I'm pretty sure the capacitor is actually fine. Just a little desolder works pretty good. Just let it heat up until the solder starts to melt, and wiggle it, and let the vacuum pump do the work. Just like so. So we just check this capacitor really quick. Yep, 1933 nano, or 2 micro. Our diode with one leg lifted up here. Yep, so the green is on our cathode. That is correct. Be number 2. And the other one, yep, the red's on the cathode. That is correct. So even though I thought it was a little corrosion on that diode, and it did check okay with the meter, and it does check fine out of circuit. So another thing is it's kind of a bad solder joint there on this white wire. I noticed it when I first took it apart, but I owned it between that green cap there, which is C5, and all the way back. Instead of doing it here, I did it all the way back to this board, and it does have great continuity, 0.01 ohms, so no issue there. It's just not pretty. It would check this little Zener diode D4 here. It's a 4.41 Zener, so that checks well. I've also gone through off camera and I have checked this diode here, which checks fine with a normal diode check. Resistors seem to be in tolerance, so it's going to have to keep looking. And this is a little MPN BJT, gain of 16. I mean, everything looks okay with this little transistor. And even though the high voltage part was working fine on this, I thought checking this TIP 41CL, it was actually not showing right on here. And I got out my old GM328 and it shows like it's damaged or unknown as well. Sometimes that's just because it's in circuit, and it's more than likely because the output's going to a transformer. But just to be safe here, I am going to undo the leads on this and check it. We'll be right back. And yeah, with 2 leads unsoldered, it definitely shows that it's the NPN 123 as base collector emitter. That's exactly what the data sheet shows. So it was just the fact that it was coupled to a transformer. Sometimes in circuit checks, you know, they're just not 100%, of course. So, and sometimes that will get you. So I'm going to hook it up to this one and make sure it reads the same. So let's just see what this one here reads. And it does. A BJT NPN, gain of about 78, very similar. So very happy with that. Since I had no trouble with the output across this cap, I was almost 100% sure this capacitor and transistor here was fine, but I still wanted to check them, especially since it didn't look good in circuit. So 116 nanofarad on this cap. Yeah, it's supposed to be 68 nano, so it showed about 100 on there, was it? And then here we're showing 72 nanos, so that's good. Yeah, removing one lead on this cap, it's supposed to be about 100 nanofarad. We're reading 97.7 nano, so that one's good. And this little small one seems to show fine in circuit. It's a 153J or a 15 nano, and it checks out fine with both meters. Just double checking each other. So that all checks good. I think it's nothing on this board. I am going to hit this solder joint here that does look weak, but again, I think I said previously I owned from there all the way to here, and it was fine. So unless it was hit or miss, I'm just going to take time to put all my leads back in and solder, and we'll be right back. Okay, my last one is this cap here, the large 2 microfarad cap, and we'll be done putting the leads back. Just a little drop of rosin flux here. Helps the solder flow so much better. Have plenty of flux. And there we go. All that's complete. I have scraped back on this solder mask. You can see that I have scratched back with a Stanley knife, with a little hobby razor blade knife, and then scrape a little bit with the screwdriver. And I'm just going to bring that and build that up on that trace a little bit, and we'll just secure this connection. So I really just have the same thing here where it's just sporadically firing. If I go into a certain, just say 20 degrees here on the display, I'll let you see this. Taking care to only touch the phone there, since that's almost 400 volts across that. Just always be careful with high voltage, of course, with everything you do. So we have some issue here with the triggering mechanism. Either the calculation going into the chip or simply the chip pin out. I'll try to have a little bit of a data sheet up here for this STC12C5604AD. Don't know much about it other than that's our output pin there, one of them. Even though we give it our best shot, no success on this one. And sometimes I don't post videos that I'm not successful on just because it may not help anybody. I'm definitely not scared to admit defeat. I get defeated quite often. So on this one right here, you know, we did not win on this one, but is there anybody else out there who might have more experience or know why this microcontroller might not be outputting to our flash output to flash a timing light? So if there's anybody out there with more experience or seen that before, or if there's something I should be checking here, even though we get an RPM reading, so I don't think it's anything to do with inductive pickup, but if I'm wrong, please share in the comments. Someone who may have a lot more experience, since this is the only one I've touched. It don't take much to be more experienced than I have with this INNOVA 5568A timing light. So I'll probably post this video because maybe it'll help somebody else through troubleshooting. Maybe they have a different issue. I didn't really figure out a whole lot about it, but hopefully you found the video somewhat helpful. And maybe somebody out there will post in the comments and help us out if we're still digging into it. So thanks so much for watching, guys. I'll have a link in the description for some of my most used tools and items that I really like on my bench, including, you know, board holders and testers and some of my soldering tools. And any link that you click on does support the channel, and I very much appreciate it. Thanks so much for watching, and God bless.